Hey everyone, welcome back. This is the third and the final part of the word ladder problem explanation. Please watch part 1 and part 2 if you haven't done that already. Okay, now let's look at the code. So here we have the begin word and the end word and this word list dictionary. So we are trying to find the length of the shortest transformation sequence from the begin word to the end word and also all of the shortest transformation sequences from the begin word to the end word. Now in order to calculate this, we have a function called find ladders. So this is like the driver function that calls BFS to build the hash map and find the length of the shortest transformation sequence, and it calls DFS to build all of the shortest transformation sequences like we saw in part 2. Okay, now let's look at each of these functions in detail. So like I said in the whiteboarding, so as and also as the name indicates, so we are doing a breadth first search, and the data structure that we are doing is using is a queue. So initially we offer the begin word to the queue and start processing the words in the queue level by level. So, so we process the words until the queue is empty, until the queue is not empty, and until we haven't found the end word. Okay, now initially we determine the size of the queue. So that will tell us how many number of words are there at that particular level. Now we iterate through each of these words at that level. That is, we poll one word at a time and start modifying the characters in that word one by one. So initially we start with one character. So this is the part where we are modifying the characters in that word. So we start with one character and replace that with characters from A through Z. And we form a new word and check if that new word is part of this word set. If that is the case, then we offer that new word to the queue and we also mark that word as visited. So at a particular level, we are checking if the new word formed is part of the word set, and we mark it as visited, and also create a mapping between the current word and the new word. Now, whenever we find the new word to be same as the end word, then we mark this flag end word found. Okay. Now, once we process one character at a time, we replace the original character back and start modifying the other characters. Okay. Now, once we are done processing a particular level, we remove all of those words that were marked as visited at that particular level here. And also we increase the number of levels. So we continue this until the queue is empty and we have found the end word. Okay, once we are done processing all words in the queue and we have found the end word, so that means we have processed all the levels in the queue. So this level here will indicate us the total number of transformations from the begin word to the end word. And this hash map here, word map, will contain each word and its transformation set. So now we will use this hash map to build the actual transformation sequence. So let's get back to the calling function. Okay, now let's build all of the transformation sequences. So this is a list of string. We'll also have an intermediate trans sequence list. So this is a list of string, and this gets updated dynamically. So we initially add the begin word to this trans sequence. And now let's look at this function DFS. So this is our function that builds all of the transformation sequences. So this is a recursive function, and the arguments to this recursive function are begin word, the end word, this trans sequence, and all trans sequences output list. So now let's look at this recursive function. Okay, for any recursive function, we need an exit condition, and this is our exit condition. So let's come to this exit condition in just a minute. Okay, so what we do is we take the current word. Initially, our current word is nothing but the begin word. So we obtain all of the transformations of the begin word using this word map. And so this is the list of transformed words. So we iterate through all of these transformed words. Now we add one word at a time to this transformation sequence and begin this recursive call here, DFS. So a call to the same function. So until when will we do this recursive calls? So until we find out that the current word is equal to the end word. So that is our exit condition. Whenever we find the end word, then we make a deep copy of the transformation sequence and add it to this output. once we find out one transformation sequence, now we want to explore all other possibilities. That is, we backtrack. We That is, once we come back from recursion, we remove the last word from this transformation sequence and explore other possibilities until we find out all of the shortest transformation sequences. Okay, I'll suggest you to play with this code here. Now let's run this complete code. And for this example here, okay, so the total number of transformations is 5, the length of the shortest transformation is 6, and the list of all transformation sequences are this one here, hit, hot, lot, log, cog, and cow, and this one here. So I will suggest you to go through this code again, and please do leave a comment below if you think you learned something new from this video. And once again, thank you so much. Bye.